So, today is March 19th, 2019, Oak Hill, Florida, and we're going to hear about the space program.
From whom?
I don't know, we're going to find someone smart. You want to talk about your
Yes,
experience?
I'll do that.
So, when did you start with beach aircraft? And what was your initial role when you first started working for beach aircraft?
X-ray technician.
And when did Beach start working with the Apollo program? How long had you worked there? Maybe 6 or 7 years?
No, about a year and a half.
Oh, okay.
I was the first employee hired for the Apollo program at Beach.
Really?
Beach got a contract for building, designing, and developing the breathing oxygen tanks for the Apollo program to go to the moon. And they moved their plant to Boulder, Colorado, their aerospace plant, so they could build it all out there next to the university, because they would need a lot of help out of the university. And when I started, they didn't even have a X-ray lab where we were going to X-ray all the welding that was done on the program. I got a chance to design the X-ray lab, and I talked to people at Kodak who were going to supply all the film and chemicals for us. And they explained to me what needed to be done to build this lab. And the protection would be thick walls of concrete. I made those walls 36 inches thick and built a very large room with overhead doors so we could get any size piece of equipment inside to X-ray it. And next to that, I had, again, on the other side of the 36-inch walls, a development lab where we develop the film and view it. At the beginning of the Apollo program, no one knew how they were going to accomplish all this. They had to carry enough oxygen with the astronauts to make it all the way to the moon and back. It was decided the best way to do it would be in spherical vessels. Titanium would be used for the oxygen tanks, and nickel for the hydrogen tanks. You needed the two gases in order to combine them and generate electricity, which is fine, beside the point here. But if you've never seen or witnessed liquid oxygen or a liquid gas, they cool it to the point it's some 300 degrees below freezing, below zero. When it gets that cold, it appears to be in a constant state of boiling, because anything you put it in is going to be warmer or hotter than the gas itself. So it's bubbling and outgassing and creating this huge cloud. If they put that in a spherical vessel and take it to the moon, they'll have all the oxygen gas they need for breathing. One tank would do it, so they put 2 tanks on. And that was the style then. Overkill everything. In order to develop the tank, we built a spherical tank. We did. The company did. Built a spherical tank that was going to be vacuum jacketed. The first tank that was built, they wrapped that before they put the outer tank on for the vacuum jacket. They covered that with gold foil, plastic gold foil. And I got a chance to go to the company in Minnesota that produced that gold foil and watched it being produced. I was by then a critical process engineer. And anything that was critical to the program, I was going to have to witness and verify that they were doing it right. Well, little did I know about that. I would question people to find out what it is you're doing and what can fail in that process. And once I discovered that, I would verify then that they had written procedures and specifications and people who were going to monitor that to make sure it happened correctly. And that's pretty much the job I had to do.
So at this point,
Yeah.
had the Apollo program been into orbit yet?
No.
So how did they know it would work?
We were testing it.
Okay.
We would build what we thought was going to work and then test it with vibration that duplicated the liftoff and also temperatures that they'd experience, hot and cold in space. And sometimes they would discover things that weren't going to work well for them. So they'd back up and take another go at it. And I witnessed all of these changes and attempts as we went through it. At one point, they decided they could lighten the load of the tanks if they would put a waffle pattern on the outer shell of the outer tank with raised lands on it, which would stiffen up the whole outer tank. But that was going to be too complicated. What they would have to do is put a pattern on the outer tank and cover it with an etching solution so that they could eat away or dissolve some of the metal selectively on the outside and make a thin wall tank with ridges to stiffen it. That didn't work at all, so they scrapped that idea, fortunately. But I got to go to the company in California that was going to do all of that. I traveled all over the country with this thing and had a very interesting time of it. From there, I'm trying to think of what happened next.
So this was all pre-Apollo 1? This was before Apollo 1?
Yes, yes it was.
So what must you have thought when Apollo 1 was getting ready to... How proud must you have been?
For Apollo 1?
Yeah.
Quite proud.
Yeah.
And then it didn't work.
True. So let's skip to Apollo what? What was the first one that worked?
Probably 4.
Okay.
I'm guessing now.
Okay.
It could have been 4.
I think you're right.
And when we say it worked, it means they got it into orbit, which is what they wanted to do, and started with spacewalks. That was Gemini. They started exercising the program to see what they could do with it now that they had it working. Another thing that I was more prepared to talk about, too, was some of the complications of the program. NASA was very astute with all of this. They were sharp. They decided if ever we have a failure, we're going to want to know what took place, why did it fail, and how do we verify it? They're going to have to duplicate the failure. Every piece and part that went into the program had a serial number. If you can imagine how many serial numbers that took to do this. The company bought an IBM 360 machine computer that was the one with the punch cards. And we started punch carding serial numbers with names of parts going into the computer. It got so big that had to be scrapped. We choked the computer. They boxed it up and shipped it to Wichita and told payroll they could have it. And we went back to the old style of keeping notebooks, writing all the numbers by hand. Apollo 13 failed. And immediately, again, the brilliance of NASA, they knew exactly what went wrong before anybody else did, before we knew. It was our tank that blew. And it seemed to be a failure, but it was really a success because they called and wanted to know if we had another heater the same as the one that blew up, because it was the heater that was at fault inside the tank. In a tank of oxygen, you really can't have a spark. We had an electrical heater in that tank to heat up the liquid oxygen. When the astronauts wanted more gas, more air to breathe, they would push a button or a switch and energize a heater inside that tank and boil off some of the liquid and create more gas pressure, which would bleed off into their system. And since we had a heater in there, NASA knew that had to be the culprit.
And were the astronauts still in space when NASA called you and asked if you had
Yes,
another
they
heater?
were.
Okay.
They had not yet gone around the moon and headed back. That was being decided. So, yeah, I lost my place.
That's okay. We have editors for that. Do you want a sippy?
No, thank you.
Okay. So NASA called and said, "Do you have another heater?"
We did. We knew which heater serial number was in the Apollo 13, and we had another heater assembly that was made at the same time that one was, by tracing the serial numbers. So we put that into a tank that we hadn't really used yet, but was on the shelf, and filled the tank with liquid nitrogen, which is inert and not explosive, and started energizing that heater assembly the same as we had energized the heater assembly, or that the astronauts had energized their heater assembly, and we watched as the plug in the end of the tube of that heater assembly began coming out, exposing the electrical wires to the oxygen that was in the tank.
You watched that in Boulder?
Yes.
We have editors for this too. They're magical people. Don't worry about it. So
the conditions were NASA had to pin down exactly what went wrong and why. If they could not, the entire program would be scrapped. And they had by then, Glenn had landed on the moon. That much was a success already. But we had to keep going with it and find out what actually did happen. So NASA told us they thought it was that plug being worked out of the heater assembly, because the heater assembly had a coil of heating element wrapped around a center column inside the tank, and that held the heater element in place. The heater element consisted of a tube with two nichrome wires inside. Nichrome wiring is the same as you have in a toaster, and those wires were held apart so that electricity could flow in and out of that heater assembly. The wires were held apart with a dry powder. When we presented that plan to NASA, told them that's what we thought was going to work, they knew immediately that if moisture got into that powder, it would be contained there during assembly. It would be contained, and when they energized the wires and created heat, it would steam, and push that plug out of the end, and that's what happened. I was privileged to have been part of the investigation.
So could we take a minute? Do you have a picture of that?
Yeah.
Let's take a minute and do the picture. Here's your pointer. So, let's see. There.
It's hard to do, isn't it?
It is. Okay, so can you show us, so where are the wires in the heating assembly?
If you can turn that 180 degrees.
Oops. I'm an accountant.
This is the heater assembly here, which is pictured over here. This is the heater element wrapped around that center column. And it comes up to the top, and there are two wires attached to the nichrome wires, and the connecting wires are sticking out of that plastic plug. I was the one that developed the technique for shooting the X-ray pictures in sequence to show that plug being forced out of the end as the moisture was steamed and pressured the plug out of the end. Was that your question?
Mm-hmm. Did anyone ever figure out how the moisture got in there?
Yes. When NASA originally identified that as a possible problem, they had us include a specification to the builders of that heater element that the humidity would have to be quite low on the day that it was assembled. And the humidity levels were specified, I'm sure. I went to Chicago to talk to the people at the company.
So is this after Apollo 13 is back? All the astronauts are safe?
I don't know if they were back or not,
Okay.
but it was after the event.
Okay.
And I talked to the people. And the quality control manager said, we followed the specification. But I had the documents with me that showed on the day they signed off on the assembly for that heater element was the end of a 3-day rain. I've hated anything about Chicago ever since. The movie Apollo 13 was the most accurate movie I've ever seen. They were on top of the story all the way. I cried all the way through it.
And when the event occurred, he was called immediately to come in, and we didn't see him for 3 days.
So what I'm hearing is when they first realized that there was a problem with Apollo 13, you were called in to go into work,
Yeah,
and you didn't come home for
3 days.
3 days. And so, what were you doing during that time?
We were going through all the records, checking serial numbers, and looking to see what else we had that was in jeopardy, and identifying all the other heater elements, similar to the one that blew up. We were also setting up tests to prove the theory that NASA provided us with.
And so, did you do all these calculations with a laptop,
No,
slide rule,
slide rule,
slide rule and paper?
yeah. And there were several engineers that had forgotten how to work a slide rule. I would teach classes at noon.
So the first system had failure, so how did the backup system work? Because you recognize, NASA recognized they had issues, so they had to have oxygen.
Yeah,
So, and there's a redundancy in the Apollo, so was there a reason why the second system didn't fail? Unless the parts were made at different dates.
different dates, different serial numbers on the other tank on board.
Is that just luck? Or was it planned that way?
I'm going to say yes. I don't really know. But I would think somebody was sharp enough in NASA to figure that out. They wanted to make sure they had two different parts, just in case. Those people were really on top of everything.
And so, when I was little, I remember 3 things. So the first thing I remember was going to Beach Aircraft to watch the re-entry of Apollo 13 on satellite. Were you there?
Wait a minute. I don't think you were watching.
Oh, maybe I was at school.
Yeah, I
Oh,
think
my
you were.
story's way better than so where did you watch the re-entry of Apollo 13?
On television at home,
Did you?
yeah.
And,
Re-entry is not what we saw.
okay.
What we saw was the parachutes coming down.
And so you never knew until the parachutes came down how it would work out?
I think that's right. We didn't know. Had no way of knowing.
And when you saw those parachutes, so of course I'm sure you felt relief. Did you feel pride?
Oh, yeah.
Yeah.
Apollo 13 was not a failure because we were able to do everything we had to do in order to salvage the program and identify the troubled area.
So did you get an award for your work on the next Apollo mission?
Yes, on Apollo 14. They were issuing certificates. Looked like a graduation certificate. And it was a very beautifully calligraphy presentation of my name and my contribution to Apollo 14. I knew at the time the artist at the company had been working on my placard presentation for Apollo 13. But after it happened, somebody decided who would want that.
Little did they know.
I'd give a body part to have it.
So would your children.
So how did the X-ray flow through this whole thing? Find out how the X-ray
So,
procedure worked through the whole thing.
of Apollo 13.
Yeah, of the tank,
So,
of the testing and all.
so you talked about, you developed the X-ray that showed the series, but from the beginning to the end, how did the X-ray flow through this?
How would what?
The X-ray. So what was the role of the X-ray in all of this? I remember X-raying snakes, and we'll delete that in a minute, because I don't think NASA would approve. But what were the other things that you X-rayed?
Dollar bills.
Okay, well, the other stuff. So tell us why the X-ray was important.
These tanks were put together by machining 2 hemispheres of titanium and putting them together and putting a weld around the equator and joining the 2 halves. After that, there was a plug that went into the top of the tank that had to be welded in place. And through that plug came the fill tubes and the access tubes, another tube that carried electrical wiring into the tank. In addition to the heating element around the center core, there was also wiring to electrify a motor that was in the bottom of that center core. And that motor had fins on it, so it would spin the liquid oxygen, and sling it, because we didn't know at the time what the behavior of the fluid would be once it got to 0 gravity. So we had to assume that it was going to be just scattered all over the tank and may not get to contact the heater element inside and create the boil off. So we'd spin the motor up and make sure we had some liquid oxygen that would be in contact with the heater. So we had that electric motor in there too. It was not suspect because it was designed especially for this to operate inside a liquid oxygen environment. It was safe. Fascinating program.
And so one of the other things I remember when I was little was you having to work 20 hours a day, just a few hours off. Was that during this time?
That was during the Apollo 13 investigation.
And so didn't you have to be on call where people
Yes.
had to call and
Yes.
you had to answer any question they had?
The arrangement was they didn't want to bring cots in because that would be too handy. So we were told we had to work as long as we could. We were pretty much dedicated. We'd work as long as we could and then go home to sleep. But when you went home, you had to leave your phone number where someone could get in touch with you if they needed information. And we all did that.
And did you ever have a situation where you had to call anyone?
Yes, I think you're talking about a particular situation.
I am.
I had to call and ask my counterpart where certain X-ray film was to verify some of the work we were doing in the investigation. And I knew he'd be asleep when I called him. And I was going to have to wake him up with conversation in order to get him awake enough to tell me. So when he answered the phone, the only thing I could think of saying, "Do you own your own home?" He said, "Yes, I do." And I said, "We're going to have a crew of men putting up aluminum siding in your neighborhood, and you can get a real good price."
And I imagine that woke him right up with some choice words.
It did. He came alive. He tried to come through the phone.
know exactly what Tom said.
So are you up for talking for a minute again about the failure of the equipment?
Yeah,
Okay.
I'll try.
So it had rained 3 days in Chicago,
Yeah.
but how exactly did the moisture get in to the unit?
Well, they were putting this together inside. The company that did it was actually the same company that makes nichrome heaters. No, Chromalox heaters for stoves. The coils on top of the stoves that get hot. It's the company that makes those. They made the same thing that we were using, except they flattened them out and spun them around the center. They made them for us and didn't flatten them. We coiled them around that mandrel in the center of the tank. When you put the powder in, that powder would absorb moisture out of the air so easily that if it had rained outside, that's where the moisture came from, and that's how it was picked up. It would happen the same way down here. That's why you have salt why you have rice in the salt. It picks it up out of the air.
And so they were in a rush, do you think?
The way the guy explained it to me, he said, they told the manager, the humidity is too high, we can't really meet spec and build those things. And the manager said, it's either put them together now or send the crew home. And they didn't want to do that. So they went out and they built it, stamped it as approved, and sent it to us.
And do you think there were any consequences to that?
No, absolutely not. Again, NASA was smart enough. They knew that if anything happened like this, they would rather have the answers than have people destroying records. So everyone who worked on the program was told, if ever we have a failure and you're at fault, there'll be no consequences. So when I confronted these people, they just said, what are you going to do? Nothing.
So, did you go to or not did you, but we went to a night launch of the shuttle program.
Yes.
So tell us a little bit about how that was different than Apollo, or how that was more powerful, or as powerful, I think.
It was much more powerful because there was more hardware being lifted into orbit, and they had to accelerate that, get it off of the pad, and to do so, you just burn more fuel to get it there. During the Apollo program, we knew the exact cost of every pound we put on the program. For a while, I was also managing the weight of the tanks that we were building. Whenever a change came up, adding a nut or bolt, washer, it had to go through me, and I would copy the information and recalculate the difference in weight and record that. And I tracked the weight all the way through to the finish. And I think I missed the mark on the actual weight by a washer, the weight of a washer, a very small amount. I was proud of that. I reported every week to NASA what the latest weight was that we were working with. And when NASA would call and ask for me, they couldn't remember my name. So they wanted to talk to the guy with the Mickey Mouse watch.
I can only imagine the pride. And so do you remember what the total weight was?
No,
Like ballpark though.
I wouldn't even guess.
Okay.
No.
So I just asked some questions based on what you've told me before, or what I remember that.
Right now I remember 28 pounds.
Okay. So anything that we haven't talked about that, question from the audience.
Your x-ray machine that you developed, so how fast could it take an x-ray? Because you were taking pictures of the expansion of the gizmo leaving the tank. So I'm sure that was happening really quick.
We didn't have to do that because what we did is we took a single picture of a position and would go back and energize the heater and boil off some of the liquid nitrogen that was in the tank, as the astronauts did, and then come back, and after that energization, we take another single picture. And we had a total of 3 pictures showing this plug being stepped out of the end of the tube. So it wasn't a thing that we had to be quick with.
Gotcha.
So did any president ever have any interest in a tank?
Yes.
Tell us about that.
We got
Maybe
a-
President Johnson?
Yeah. We got a call from California. North American Rockwell was a primary contractor, and we were working for them on the program. And they called and said President Johnson was coming to their facility and was going to take a tour of the Apollo program. And he was going to walk on a platform next to a mock-up of the space capsule and the support module behind it. In the support module were the 2 oxygen tanks right at eye level, and they didn't have anything that was going to be suitable. Wanted us to send 1 or 2 tanks so they could put them in that mock-up. And the only tank we had that would work, that we could send them, had a hole in the weld on the equator of the tank. The hole is generated when you weld it, when you make that weld, by a piece of contamination, lint or dust or something was in it. And as it burned up, it expanded and made gas in the molten metal, which put a hole in the weld, and it was an ugly thing. It was black inside, and it looked terrible. We had a meeting to decide, what are we going to do with that? We've got to send that tank so they can have their mock-up. We sat around a table, and several people came up with ideas of filling it with wax or something to hide it. Nobody thought of duct tape at the time. I watched a guy across the table from me sit there like he suddenly realized he had the answer. And then he shook his head, no, he's not going to do that. And I told him, I said, do you have a solution? He said, well, yeah, but I'm not going to say it. I said, just go on and say what the answer is. He said, we should take it to a dentist and have him fill it.
And did you?
Yes. Two engineers held a tank in the chair, and the dentist in Boulder filled it, and it worked perfectly.
Austin? So, what story didn't we cover? Is there anything we didn't talk about?
I think a couple of nights ago I told a story about the engineer who was afraid of snakes. And it so happens that was the engineer that came up with the idea of taking the tank to the dentist. I was walking across the parking lot, and this particular engineer was absolutely afraid of snakes. He was down on bended knee looking under a car, and I stopped and I said, what are you doing down there? He said, well, he said, I was going over to the other building, and he said, I saw a snake run under the car. And I got down and looked with him and took a pen out of my pocket. I said, you better be careful. It was a bull snake probably. And I said, those things run in pairs. Said they travel together. And I put my pen on his sock and slid it. I had to help get him off the car.
What about the enchiladas and green chili?
Enchiladas and green chili
Oh, yeah.
at NASA?
That heater tube that was in the center of the tank, when we decided to build that, NASA imposed some requirements on that. We had to prove that that assembly would stand up to vibration and to the temperatures. We had to buy an oven that would register about 200 degrees hot and several hundred degrees below zero so that we could test that. I think liquid oxygen is around 300 degrees below zero, and we would pump nitrogen gas into that oven to lower the temperature and monitor that and operate the heater in the cold temperature. When Beach Aircraft got through testing it, they tried to get their money back for that heater from NASA. And NASA said, no, you have to buy it because it's your contract and it's your requirement to test the tank or the heater. And since you had to buy that, it's yours. Well, we had no use for it, so they insisted NASA should take that back. The word came, there was a NASA crew coming through an inspection at Beach Aircraft, and they were going to take them up and show them this area where the heater was, or the oven was that we tested. And they were going to try to convince them there that we should get our money back on it. The story is they took the representatives from NASA through that department, the test facility where that was. And when they got there, somebody was cooking enchiladas and green chili in the oven.
Did NASA take it back?
No.
Anything else? That was a good one.
What they took back was the recipe.
The recipe. Any other good stories we missed?
Right offhand, I can't think of them.
So what did you think when the president canceled the NASA program?
Big mistake. I thought that was awful.
And what do you think now?
Smart. I agree.
Did you ever meet an astronaut?
Oh, yeah, yeah. Vance Brand was from our area. Whenever he would come around, he would drop in at Beach Aircraft. And everyone there knew him. And I met him, talked to him. Enough to say hello. Showed her my watch.
And did he say, "Oh, you're the guy"? Did he know your role?
I doubt it. No.
How about the astronaut in Florida during the last night
Oh,
launch?
yes. I met him. And he didn't know my role either, but I think someone told him that I had worked on the Apollo program. And he stopped and talked to me and said, "I understand you worked on the Apollo program." I froze. I didn't want to talk to him anymore. Here's a man who's going to fly the mission the next day. This was the night before his launch. They're still using the same tanks as we had on the Apollo program, on the shuttle program. And I thought, I am not about to talk to him about our tanks.
But that was also the first time he ever felt any pride, or that's the first time he ever felt that he received any real acknowledgement of the contribution they did. Because at the time the Apollo program was in effect, people thought that was ridiculous that we were spending all that money trying to go to the moon when we should be feeding the starving people. And
I actually heard people say to me, it's ridiculous to spend that much money in a single exercise. They could give that money to people and it would feed them for a long time. People who need food. I thought, yeah, that's right. You sure could.
Did you know anybody who didn't believe that we went to the moon?
Oh, yes.
No one that worked with you, certainly.
I stood next to a guy. It was after Glenn had walked on the moon. The following day, it must have been a Monday, and I was observing welding operations, and he was standing next to me. He was also a welder. And I said, I can hardly believe this. I said, here we are watching this, participating in the program, and we've got a man on the moon. And he turned and looked at me and he says, you don't think that really happened? I said, sure I do. He said, God would never let anybody go past heaven to get to the moon and do what they did. Okay.
Didn't that make you nervous that he was a welder?